Hi, for this video I'm going to show you how to answer exam questions when it comes to quadratic sequences. So here you are given a sequence 6, 6, 9, 15, and these are the four terms of the quadratic number pattern. If they tell you that this is a number pattern, and 3.1.1 says that write down the value of the fifth term of the pattern. Okay, so you have 6, you have 9, you have 15, and they want to find the fifth term. So one thing you should bear in mind is this is your first term, this is your second term, this is the third term, T3, this is your fourth term, T4. So they want us to find the fifth term, this term here. So how do you do that? The way to do this is to use this methodology. So you need to find the first difference sequence and then find the second difference sequence, and the second difference sequence is always constant. If I say it's always constant, it means that all the terms in that sequence are gonna be the same. So let me just show you what I mean by that. So the first difference is just finding a difference between the following sequences. So you're like 6, the difference between 6 and 6 is 0. So you're gonna say 6 minus 6, that's 0. Difference between 6 and 9, so there's 9 minus 6, it is 3. The difference between 15 and 9, so there's 9 minus 15 is 6. Okay, so this is your first difference. Okay, so from the first difference sequence, you need to find your second difference sequence, and your second difference sequence is always constant. The terms are always constant, so meaning you need to see the same term all the way. So difference between 0 and 3, so it's 3 minus 0 is 3, and difference between 3 and 6 is 6 minus 3, that is 3. And we are expecting this, we're expecting the difference to be the same, the second difference. And so since the second difference is always be the same, so we just have to put another 3 here. Why? Because now we want to work ourselves up. We want to go up to T5. So we work ourselves down, which is cool. Now we're going to work ourselves up to T5. How do you do that? Let me show you. Let me just show you the pattern. That's why they call it a pattern, a number sequence, because there's like sort of a pattern that these terms follow. So check this out. 0 plus 3, it is 3. 3 plus 3 give you 6. So 6 plus 3 is going to give you 9. And check this out. You can also do the same thing in the first difference. 6 plus 0, that's 6. 6 plus 3, that is 9. 9 plus 6, that's 15. So 15 plus 9 is 24. So basically T5 is 24. There is another way of actually calculating this, but for now this is the information we have, and this is the best method to actually calculate this. But I'm going to show you another way to calculate this given other information. Okay, so let me just jump to 1.2, and immediately after that I'll show you how to calculate T5. Now 3.1.2 says determine a formula to represent the general term of the pattern. So they want us to find a formula to represent the general term of the pattern. So let me just give you how the general equation of the quadratic sequences look like. an squared plus ban plus c, but we need to know what is a, we need to find b, we need to find c. Then if you know a, b, and c, then you can now say this is the general term of this sequencing. Okay, so what you need to know is this value here is equal to 2a, right? Regardless of what value is, every time when you see this value, just know this last value, this first value of the second difference is equal to 2a, and this first value of the first difference is equal to 3a plus b is equal to obviously equal to 0. So it's 3a plus b is equal to 0, and the first term of the sequence is equal to a plus b plus c. Always have to remember this. And with this equation, then we can find a, b, and c. Let me show you how to do that. So we can say, now you see that 2a is equal to 3. So we can divide by 2 on both sides because we are solving for a. And we can say 3a plus b is equal to 0. So you see that we know a is 3 over 2 plus b is equal to 0. 3 over 2 times 3 is 9 over 2 plus b is equal to 0. So b is negative 9 over 2. And then the last one is a plus b plus c is equal to 6. So if a plus b plus c is equal to 6, we know a is 3 over 2. We know b is negative 9 over 2. Do you see what I just did there? It's plus, and then b is negative 9 over 2. I put the bracket there. Why? Because you don't have to lose the negative. It's important. It plays a huge important role in this equation. Okay. Oh, this is positive, not negative. Did I just write negative there? Let me remove it. Cool. So this is 3 over 2. Positive times negative is negative. So it's negative 9 over 2. And then 3 over 2 minus 9 over 2. I mean, you can punch 3 over 2 plus minus negative 2 on your calculator and just get the answer. But I'm just showing you step by steps. So 3 over 2 minus 9 over 2 is basically 6 over 2 plus 6 plus c is equal to 6. And 6 over 2 is 3 plus c is equal to 6. Therefore, c is 6 minus 3. So if you take 3 to the other side, it's going to be 6 minus 3. So, excuse me. This is 3 over 2. This is, so we are here. Let's just go back here. I missed the sign. 3 over 2 minus 9 over 2 is negative 6 over 2. And then you take negative 6. So negative 6 over 2 is negative 3. Now you take negative 3, put the other side, is positive 3. So it's going to be 6 plus 3. So your c is equal to 9. Good. Now let's go back. So now you know your a, you know your b, you know your c. Then you can just substitute them in your equation and get your answer. Okay, let me just go to the second page and rewrite the general equation of a quadratic sequencing. And then they substitute the values. So you know your a is 3 over 2. Say 3 over 2 n squared. And you know your b, I don't have to write plus there because we know b is negative 9 over 2. So you just write negative 9 over 2 n. And you know your c, we just find c here, c is 9. This is what we're looking for here. Determine the formula to represent the general term of the pattern. So this is the formula that represents the general term of this pattern. And so I promise you another way to find T5. Okay. So now let's say you are given this formula. Excuse me, let's say given this formula, Tn is equal to 3 over 2n squared minus 9 over 2n plus 9. So what you can do is you can just substitute where there's n, you just put 5 when you're given the general term. So you can say 3 over 2, where there's n, just put 5 squared. This is minus 9 over 2, where there's n, you put 5 plus 9. So T5 is, so you can just punch this in your calculator and say 3 over 2, 5 squared minus 9 over 2 times 5 plus 9 is equal to 24. It is equal to 24 as we expected. 24. T5 is 24. So if you're given this information the way we've been given in 3.1.1, this is what you're going to use. Now let's say you are given already, now you already calculated the general term, then you can just quickly substitute it in your general term and get the answer. Make sense? Awesome. Cool. Now let's go to the last question. 3.1.3. which term of the pattern has the value 3249? So 3249. So when they say term, just know that they're talking about n. So which n of the pattern has the value 3249? They want you to find n. So you have the equation. You have the equation Tn is equal to, this is the general equation, this general equation here, 3 over 2 n squared minus 9 over 2 n plus n. This is a general equation, so you're solving for n. What you're going to do is you're going to just substitute Tn to be 3249, 3 over 2 n squared minus 9 over 2n plus 9. And then take 3249 to your right and you change sign to be negative. So you're going to have 3 over 2 n squared minus 9 over 2n plus 9 minus 3, 2, 4, 9 is equal to 0. And then you can just minus 9. So you can say 9 minus 3249. So that's basically negative 3240. And you can use your quadratic equation formula to find n, to solve for n. So you have n is equal to minus b plus or minus b squared minus 4ac over 2a. Okay, let's just go to the next form so the thingy. But let me just substitute it here, n, and then I'll copy it to that side. So you have negative. Now what is your b? This is your b. Your b is negative 9 over 2. Your a is 3 over 2. And your c is negative 3024. Don't forget the negative. This is very important. Don't forget the negative if they are there. Just take it the way it is. So you have negative b. So b is negative 9 over 2. Plus, see what I just did there? Always do that. Negative 9 over 2 squared minus 4a is 3 over 2. C, negative 3240. And then you divide by 2a. A is 3 over 2. Okay, let's just go to the next page. I'm going to try and copy this to the next page, okay? Copy, paste it here. Voila. Okay, cool. So you can just punch this in your calculator and say negative 9. So negative. So this is two negatives. So negative 9 over 2. Plus, we're going to start with plus and finish with negative. Negative 9 over 2. And then you square that. Minus 4 times 3 over 2. Times negative 3240. Divided by 2 times 3 over 2. What you get? You get 48. N is equal to 48. Or n is equal to, now what you have to do is, we use positive, now we just have to use negative. Just go back to your calculator and remove that, substitute that positive, replace it with negative. When you do that, you're going to get that n is equal to negative 45. Now, this is not the correct answer. You cannot have two n's. Why this is not correct answer is because your n should always be greater than 0. Okay? Your n should always be greater than 0. What does that mean? It means that your n can never be equal to 0. Remember, n is the position of the term in the sequencing. N is the position of the term in the sequencing. So we cannot have 0 position. If you have a 0 position, that means there is no position for that term in that sequencing. So you cannot have n is equal to 0. That's first thing. Second thing, you cannot have n to be less than 0. You cannot have a negative n. Why you cannot have a negative n is because we're talking about positions. N is a position of the term in the sequencing. So you cannot have a negative position. You cannot have a term standing in a negative position. You cannot have a negative position. So that's why this n is equal to negative 45 is not applicable. So our correct n is this one here. N is equal to 48. Make sense? So the question is, which term of the pattern has a value of 3749? That term is equal to 48. So this is the type of question that you're gonna get when you answer sequences in quadratic. And basically this is it in quadratic sequences. All the questions you're gonna ask, they're gonna evolve around what I just taught you. So basically what I'm saying right now is, you know, quadratic sequences, and you can actually get the total. Here is like 9 marks. You can get all the marks that you want from quadratic sequences. Awesome.